I just want to thank Sunshine and everybody for putting this on at the Metcalf Institute. It's a great opportunity. I have been working over the last several years in Minnesota working with the media, and I've had a wonderful experience working with them, especially people who cover science writing or science journalism are really passionate and careful about what these mechanisms are and trying to get the story right, and I really appreciate that as a scientist. I'm going to talk today maybe about a cautionary tale. Don set up what's going on, where we're headed. Julie focused on the regional aspects, and I'm going to talk a little about it as a cautionary tale about weather and climate, and in particular extreme events, and focusing on the upper Midwest as well as Julie did. I will also argue that I'm a climate skeptic, but not in the way you think probably, like Don used the word skeptic earlier. I am a climate skeptic, but in a different way, and skeptics it's a good thing. A couple years ago, one last little story here. A couple years back, I did the Yale Forum on Climate Change put on by a guy named Bud Ward, who maybe Sunshine probably knows well. And that serves much the same function as this sort of an event. And in it, I was presenting some relatively cutting-edge new research on this buzzword, the polar vortex, which we've certainly known about in our field, but was discussed quite a lot a couple years ago because a paper came out by a woman named Jennifer Francis at Rutgers University and a guy named Steve Avris at University of Wisconsin. And in that study, I was presenting kind of the cutting-edge theory on this. And in the room was a guy named Tony Broccoli, who's also actually at Rutgers University. And he said, I think, we should be really cautious about talking about this. I don't think this even works. And I said, well, I think we got to do a little more research on it. But it turned out, there was all this disagreement. This guy came up from North Dakota, radio TV station, came up afterwards and he said, I thought you guys were in agreement. There's this 97% number. And yeah, there is a 97% agreement, but that's on something very particular. This is AGU, our crazy conference we go to every fall in San Francisco, 20,000+ people. It's a big nerd fest. This question is what relates to this 97%. Do you think human activity is a significant contributing factor? And this was a study done out of the University of Illinois, Chicago, came out in 2009, and it said 97% of climate scientists agree that this statement is true. That's related to things like this. Don showed this a little earlier from the IPCC. This is the observed temperature change that we've seen over the last decade or last century. There's a lot of significant warming with the absence of a few places like the southeast US that was discussed and over the ocean. In the upper Midwest, just looking on trend-based, not projections of these models, we can see some significant warming going on throughout on the annual average. And in the upper Midwest, in particular, just looking at the last 150 years or so, you can notice that pretty strong warming starting in the 1970s with a lot of variability and heading on up from that. That's a valid assessment of the state of the climate right now. This is the 97% people agree to, the climate response. There are things that we all pretty much agree to. We agree to things like ocean acidification. We agree to ocean heat uptake. Those sorts of things are very well understood. But now when you get into the details, particularly related to climate extremes, these are these weather events, you get into things like extreme rainfall, rate, amount, frequency, intense drought, extreme snowfall. I love Snowmageddon. That was a great event. Or Snowpocalypse. That brought out the climate denier group big time. It was very entertaining. Extreme heat, extreme cold. Us Midwesterners clearly remember last winter. More tornadoes, stronger tornadoes. There was a study done last year out of Stanford that claimed we were going to see more tornadic activity in the southeast US with climate change. More hail, bigger hail. Extreme hurricanes, Superstorm Sandy type events. And then this this word polar vortex, which makes every atmospheric scientist cringe because the media won't stop using it. But these things, all these things here, are things that we just don't necessarily all agree on. I do not agree 100% with everything that was said by my two previous, but that's okay, that's good. We need that. What we're really talking about here is climate change forensics, which is kind of, there is a field called climate forensics, but climate change forensics is what we need. We need attribution of climate-related events. There's a guy at NOAA ESRL, which is a place in Boulder, Colorado, named Marty Herling, who, if you guys, any of you are going to do a story on this attribution of climate-related events, he is the single guy I would go to. And I can provide his contact information afterward. But he dissects all these little things and really looks to see if this is a robust climate change signal or not. Okay, why am I showing a doctor's office? Well, there are a million metaphors to talking about weather versus climate. Mine is a personal one. I hate doctors. I hate doctors' offices. I hate medical buildings. I can't even drive by them without freaking out. I go into doctors' offices. You see the crash cart standing outside the door and you freak out, right? I mean, has anybody got freak out in medical? No, you're all macho. Okay. I have white coat syndrome, and white coat syndrome looks like this. This is my systolic blood pressure. Can you tell when I went to the doctor? Yeah. I've got a really pretty good systolic blood pressure, but it spikes like crazy when I go in there and they want to tell me. So our average is, my climatology of my blood pressure is around 130 or 120, something in there. My extremes, my weather, if you will, of my blood pressure are those peaks that you can see, and you're probably going to ask, well, why do you go to the doctor so often? Well, I had what is called a transient ischemic activity with my brain. I had a blood clot in my brain, and I had a series of strokes. These are very small strokes. They're often a precursor to a larger stroke. And these events in here, this was not when I had this last year, but you get blood clots in your brain, and these blood clots can cause these micro strokes to occur. And so that was my extreme event. And my doctor said, well, it's probably because you have high blood pressure, because every time I go in, I had high blood pressure. Well, what we really found out was it was blood clots in my brain that were caused by a genetic predisposition that I have to producing clots in my body. So now I'm on blood thinners for life, and it's great as long as I don't fall down or hit my head. So when we're specifically talking about weather and climate, this is I feel like I shouldn't have to go over this, but we really do every time we all talk about this stuff. Weather represents the conditions of the atmosphere over a short period of time. The climate represents the average weather over a much longer period of time. That is a very important distinction. It's an issue of temporal resolution, if you will. The problem with this is that low frequency events are by definition extreme because they do not happen very often. If they happened a lot, they wouldn't be extreme, and then we wouldn't be talking about them in that way. The problem with these low frequency events is we have very few samples that we can draw from. Even with our best long-term records, we don't have a lot of these events showing up. So we have to do a lot of statistical analysis to try to pull out why extremes might be changing with climate change. We can use models, and that's a valid way to go as well, but you have to go very cautiously. Why are these so difficult? Well, I call them episodic variables. They're the most difficult to attribute because they can occur over relatively short time and space scales. Convective precipitation, which causes the extreme events, and I would argue the reason Julie talked about summertime disagreement in models, and we think we know exactly why that's happening, at least the work that we've done at Minnesota, and I'll talk about that in a minute, but convective precipitation is very small scale, frost, fog. These can be things that are relatively small scale, weather type events. Severe weather in particular, supercell thunderstorms. There's a lot of great work going on at NOAA, National Severe Storms Lab, guy by the name of Harold Brooks, another great person to talk to if you want to talk about what severe weather is doing. Here's an example from the great Weather Bureau office in downtown Minneapolis in 1926. These are just beautiful old books. The records, the handwriting is gorgeous. They got 1 inch of rain in 7 minutes. It fell on pretty much the building in downtown Minneapolis. Everywhere else was fine. 42-mile-an-hour winds, 1 inch of rain, 7 minutes, floated up all the all the roadway tiles, which were made out of wood. I don't know why in Minneapolis they used wood for road tiles or pavers, but they all floated up. It was a very great story. But here's an example where you're going to get this in the data record, this extreme event that occurred over a relatively short period of time. So you have to be aware of whether that's realistic. Now, with that said, there is clearly a signal. Don talked about it, Julie talked about it. If you look at 3 inch or more per day rainfall events in the upper Midwest, this would include all the regions of Michigan, Illinois, Iowa, Minnesota, and Indiana. You see this pattern emerging where as we get into the 80s, 90s, and onward, we see this increase in these large events. So this is definitely a trend that we are concerned about. I'm throwing this out here to impress you because it's thermodynamically based, but just ignore the equation on the left. You will hear oftentimes people talk about this relationship that says, well, as it gets warmer, the atmosphere holds more water. Well, we don't like to say it actually holds more water, but there is more water in the atmosphere when it is warmer. And so if the atmosphere is warming, we would then say, well, we should have more water vapor, which means we should have more precipitation. And in fact, 1 degree of warming should relate to an average of 7% increase in water vapor. That's on a global average, though. If you look regionally, things are very different. Our summertime precipitation driven here in the Midwest is driven by something called the low-level jet that pumps a lot of moist air up from the Gulf of Mexico. That is a driver that trumps this Clausius-Clapeyron relationship. So there's a lot of complexity in understanding how these extremes change in the future. Now, June 2012, we got a major flood in Duluth, Minnesota. Duluth is right in here. Gorgeous place, actually. Very, very strong, heavy rain event that occurred over Duluth, and everyone said, climate change. And it just makes us cringe because it's one event which may or may not be related to climate change. In fact, there had been another event there in the 1970s of equal magnitude, just a little bit to the west, similar event. And if you go back in the record, there are events that occur like this in Minnesota. However, there's some lovely mess that resulted from that. However, in 2004, we had a major flooding along the Iowa-Minnesota border, produced a lot of rain. August 18th, 20th, 2007 produced a lot of rain. You can see there that's over 14 inches of rain. And then in September of 2010 along the southern part of Minnesota. 3 events over the span of 8 years produced major, heavy 1,000-year flood events in one part of the state. Now, if you look at the details of it, this is something called Atlas 14, which provides an assessment of the extremes and return periods on extreme precipitation. There is this somewhat of an arc stretching from southern Minnesota up around the Twin Cities back down to parts of Minnesota or Wisconsin, includes a little bit of Madison in there. That is an area known by the meteorologists and the climatologists in the state climate offices as being a really interesting area to focus on. We're seeing a lot of extremes in that particular area that shouldn't be returning that frequently. And then you can see it stretches down into parts of Illinois as well. So this is something that we're really focused on, we're concerned with. 3 events over a matter of a short period of time is something that may have a climate change signal on it, and we need to understand that better. Now, if you decide to use a numerical model, a GCM from this CMIP5 archive, we work with the CMIP5 archive, all these colors in here going down to just to the black are a set of 20-something CMIP5 models that simulate the extreme precipitation, so 6 hourly precipitation. The bulk of the reality is these black ones in here, and there's a little bit of disagreement on those, but what it says is that the majority of your precipitation falls in small rain events. And we all know that, right? It falls a little bit at a time. If you go to the GCMs, in the observations, as you move outward to higher and higher levels, precipitation amounts, rates over 6 hours, you tend to get more and more heavy rain. They occur less frequently. GCMs, however, cannot simulate these extremes very well. They can't produce the right number over time. They produce a lot of light precipitation events at the expense of heavy precipitation events. They get the total amount right, but they don't get the extremes right. And that has to do with the scales at which these models are run that Julie just referred to. Minnesota tornadoes by year, if you look at it, it looks like there's a big uptick right in here. You see that there? You know what that is? That's the adoption of Doppler radar. Doppler radar allowed weather chasers and spotters to go out to a specific area to try to find the tornado, and that caused a big increase in the number of reported tornadoes. This is data based by the Storm Prediction Center. Although I would argue there's a really funny anomalous year there. We had 113, which was a real mess that particular year. Finally, the polar vortex, the waviness of the jet stream like this. This is this last winter, big troughing over the eastern third of the country or eastern half of the country, allowed an incursion of a lot of cold air down into the upper Midwest and the eastern third of the country. If you look, in fact, though, at how much of the Earth was in the northern hemisphere was cold during that time, below -5 degrees Celsius or 22 Fahrenheit, this is the average here, and this is what these temperature was doing this particular year. You can see that for most of the year we were below average. The rest of the planet was in a big warming. If you remember the Olympics in Sochi, they were doing ski jumping at 60 degrees. You know, that's pretty warm. A lot of the northern hemisphere was under deep warming at that time, including places like Alaska. And if you look at something like March of 2012, you'll see here we had this very strong jet curvature or trough that extends down into the country. Winnipeg, Canada was at 80 Fahrenheit. Phoenix, Arizona was at 42 Fahrenheit. So think about that. We were up in the Twin Cities. We hit 80. It was a very, very odd warm event. A lot of this is a psychology problem. I'm going to let you read this for a second. And if you talk to any of the old timers in the Twin Cities, where I was, they all said, hey, you know, it was a lot colder. I can remember back in 1947, it was, you know, X number of degrees. It was a lot colder back then. Even though it's cold, was not necessarily drastically cold. And I think we lose sight of it when we spend all these years in this warmer climate. We have to think about this sort of psychology thing going on. So I would argue, in summary, climate awareness is what we really need. We use these events, whether they're climate change driven or not, to highlight the vulnerability of the Earth and the people who live on the Earth. We need to become more resilient. We got to retune our systems, our agricultural systems, different hybrids, whatever, flood management, water management, all that stuff, ecosystem management, to be more resilient to these changes. Because if it is climate change, then we're stuck with it. We need to act to mitigate additional warming. We need to study the problem more and replicate, replicate, replicate. When you get a story that seems like it's too good to be true on climate change, and climate change is going to cause all the monkeys in the world to die, make sure that you have somebody to back that up with, another study, another source that will provide you some sort of sense of what's going on. So with that, I'll wrap it up. There's my contact information. Thank you.